example, we have sodium nitrate, zinc, and sodium hydroxide reaction. We obtain sodium zincate, ammonia, and water particle. Okay, so let's use two previously mentioned methods. The first one, atomic. I mean the first one utilizing the changes of only atoms' oxidation states. So we need to find what change his oxidation state. So let's start from the sodium. In sodium nitrate, oxidation state of sodium is equal to +1 because nitrate anion oxidation state is equal to -1. This is neutral particle. Here in sodium hydroxide, also oxidation state of sodium is equal to +1. In sodium zincate, the oxidation state of sodium equal to +1. Okay, so there is no change of oxidation state of sodium. But firstly, let's consider this very interesting compound. I mean sodium zincate. Yes, sodium zincate. Here we have sodium atoms, zinc atom, and oxygen atoms. Oxidation state of oxygen atoms, every single, is equal to -2. Therefore, the total given by oxygen atoms is equal to -4. -2 times 2 gives us -4. Sodium, in such a cases, always and always equal to +1. So 2 sodium atoms give us +2. So, as we know, this is neutral particle. The net charge, the net oxidation state of this particle is equal to 0. So, the oxidation state of zinc here should be equal to +2. Okay, so let's get back to considering our oxidation states in this example. So we know that sodium do not change oxidation state. What about the nitrogen? We have nitrogen in nitrate anion, and on the right side of this reaction we have nitrogen in ammonia. In ammonia, it is also interesting example. In ammonia we have hydrogen, yes, though there are some exceptions about hydrogen. However, mostly hydrogen oxidation state is equal to +1, yes. There are some exceptions. We are not talking in the case of electrochemistry about these exceptions, but in the case of ammonia, hydrogen atom oxidation state is equal to +1. So from these 3 atoms we obtain +3. So ammonia is a neutral, in the case of the charge, neutral particle. So the oxidation state of nitrogen here in this particle is equal to -3. Okay, -3 plus 3 give us 0. Why hydrogen is not equal to -3 and ammonia to +3? Because the electronegativity of nitrogen, is higher than electronegativity of hydrogen. Nitrogen is more electronegative. So nitrogen attract the pair of electrons, attract the bonds, attract the electrons that create bonds into his side. Yes? So the oxidation state of nitrogen is equal to 3 in this case. Okay, so we found that nitrogen changed his oxidation state. Okay, so we know now that nitrogen undergoes reduction reaction from +5, because we already knew on the previously considered example that nitrogen oxidation state in nitrate anion is equal to +5. In ammonia it is equal to -3. So nitrogen is reduced. Yes, the oxidation state of nitrogen is decreased. Okay. Oxygen, here oxidation state in nitrate anion is equal to -2. Here in hydroxide also -2. In zincate also -2. And in water particle also -2. Okay. Zinc. Here we have a metallic zinc with oxidation state equal to 0. Here in sodium zincate, oxidation state of zinc is equal to +2. So this is a change of oxidation state. Zinc undergoes oxidation reaction. The oxidation state is increased. Okay, what about the hydrogen? In hydroxide, oxidation state equal to +1, in water also +1, and as I said, in ammonia, hydrogen oxidation state is equal to +1. So there is no change of oxidation state of hydrogen atoms in this reaction. Okay, so let's utilize the first method. So the method concerning only atoms. Oxidation reaction. Zinc, metallic form, to zinc with oxidation state equal to +2. And of course we obtain 2 electrons. 2 electrons. Okay. Remember that at some step of this method we need to use this zinc with oxidation state with +2 as a cation with the charge equal to +2. We need to use it as a cation to balance the charge. On the right side, the charge is equal to 0, 2 plus 2 electrons give us 0, and here is of course equal to 0. Okay guys, so let's write reduction reaction. Okay, nitrogen with +5 plus, oh my god, 8 electrons, and we obtain nitrogen with the oxidation state equal to -3. So 8 electrons. Okay. +5 plus 8 electrons. So +5 plus -8 give us -3. On the left side, -3. Here, of course, we have -3. So the charge as well as matter is balanced very well. Okay, so what we need to do in the next step? We need to balance the electrons between these two half cell reactions. In the oxidation reaction we have 2 electrons, in the reduction reaction we have 8 electrons. Okay, so one atom of nitrogen consumes 8 electrons. So this atom needs 8 electrons. These 8 electrons could be provided by 4 atoms of zinc, metallic zinc. So we need to multiply the oxidation reaction by 4. Okay, and we will obtain here 4 zinc metallic atoms, 4 zinc atoms with the charge equal to oxidation state equal to +2, and of course 8 electrons. Okay, so we have very well considered oxidation as well as reduction reaction. And what else? We need to write, of course, the overall reaction. Yes, we need to write overall reaction. So, okay, I will just make a space here for us to write it. And, okay, so considering the substrates, 4 atoms of zinc. Yes, because we already multiplied it by 4. 4 atoms of the metallic zinc plus nitrogen give us 4 atoms of zinc with oxidation state +2 plus ammonia. Nitrogen with the oxidation state equal to -3. Okay, so we can now we are sure that we can put 4 in the front of metallic zinc. I will show you this more properly, more readable. Okay, 4 in the front of metallic zinc. There is no way to avoid 4 in the front of sodium zinc. We need to put this number here. Okay, so we have 4 metallic zinc, we have 4 particles of sodium zincate, and what else? We know that before, in the front of the particle containing this atom, the nitrogen atom with oxidation state equal to +5, must be 1 mole or 1 particle of this compound containing this nitrogen atom. This nitrogen atom containing particle also only 1 mole or 1 particle. So in the front of ammonia and in the front of sodium nitrate, there is no more than 1 particle. Yes? So we do not fill in the front of these particles. Okay, so if we know that there is only 1 particle of the sodium nitrate, and we know that we have 8 atoms of sodium on the right side of the reaction, so we are sure now that we need to put 7 in the front of sodium hydroxide, because we need in overall 8 sodium atoms on the left side as well as right side of this reaction. Okay, so the rest is very simply. We have 7 sodium hydroxide particles, so we have 7 hydrogen atoms on the left side. So on the right side we also need to have 7 hydrogen atoms. In the ammonia we have 4, so we need 2 particles of water in which we get 4 hydrogen atoms. Okay, it's all. We fill the whole reaction equation. Okay, so let's consider now the second method, yes, for this reaction.